So hi guys, once again we are trying to solve this. Right, this is from CMI 2025, question 6 part 8, and this is a very nice and very sweet question. So let us try to see uh, what's in the question. So basically we are let R plus, I mean all x belongs to R such that x greater than equals to 0, and they are saying that basically they are defined a fractional part of x, right? Yeah, so basically they have defined the fractional part of x. Now they are consider the series. They are giving us a series which is nothing but summation n from 1 to infinity fractional part of x by n by n. Now they are saying pick the correct statements from below. Right. So so yeah. Um, okay. The above series converges for all x belongs to r plus minus z. Okay. The above series basically diverges for some non-negative integer x. Okay. Basically the convergence of this summation, and the above series define a continuous function in the neighborhood of half, and the above series defines a continuous function in the neighborhood of 1. Okay. So basically okay. So uh, let us write our fx as summation n equals to 1 to infinity. So I am not writing frac every time. So this is a very standard notation, curly braces x by n by n, right? So this is the function. This is our function. So are they saying that the above series converges for all x? So let us first, try to let us see let us try to mm, manipulate this function a bit. So uh, so we can actually write this as summation n 1 to infinity x by n square minus summation n equals to 1 to infinity box of x by n by n, right? Because we know that fractional part of x as given here is nothing but x minus box x, where box x is the greatest integer function, or we can say it's the float function. We can also use this notation, but I am going to use this. So yeah, so okay, now what? Now it is saying the above series converges for all x belongs to R plus minus. So let us take, say, x belongs to R plus. Okay. Now let us see. Let us check. Now, so basically this part summation equals 1 to infinity x by n square. This is convergent, right? It's p series, right? So it's here p is greater than 1, so this is convergent. So this will be x n equals to 1 to infinity. Okay, let me write it properly. 1 by n square, and this we know as pi square by 6. So x pi square by 6. Okay. So this is this part, right? So this is this part. Now what about this? Now we know since x belongs to R plus, I mean, so there exists an integer such that we know this, right? We can have an integer such that m is greater than x, right? So which would imply that x by m is less than 1. I mean, mind you, we have calculated this because this will be x pi square by 6. Now, what about this? Right? What about this? Now, after finite terms, so this will be after finite terms, this will go to 0. This whole thing will go to 0 because because so there exists m such that x by x less than m, and x by m is you know less than 1, so which would again imply that box of x by m is 0, right? So basically our summation in 1 to infinity, basically our summation here reduces to um, so Basically, let's just say, so this reduces to n equals to 1 to let's say m minus 1 x by n by n plus, so yeah, sorry, n equals from m to infinity x by n by n. This will go to 0 because for m plus 1 x by m plus 1 m plus 2 whatever, this is less than 1, and box of something like between 0 and 1 there is 0, so this will go to 0. So only finite terms, so basically this whole summation is nothing but only finite terms, right? So this whole thing, fractional part of x by n, so this whole thing converges for all x belongs to R plus, right? We have proven this. Okay, so this is true. The above series diverges for some non-negative integer x. I mean, this is not true because like the logic we have used for this, we can. I mean, this is for arbitrary for all R plus, right? Right. Okay. So yeah. So okay. Mm, yeah. Okay. Maybe I should write it minus one. Right. Yeah. Hmm. So okay. So this is false. This is false. Okay, now it is saying the above series defines, so this they are talking about this function. The above series defines a continuous function in a neighborhood of half. So okay, so you know, let me draw a straight line. Let me draw a straight line. Okay, so say like okay, say 0, let's say half, let us say 1 here. Okay, and yeah, let us say we have got 2 here. So, so basically, now we have our f of x to be, um, okay, I have to write this once again, but it's okay. X by n square minus fractional part of x by n by n. Okay, so this is our function, and they are saying that the above series defines a continuous function in a neighborhood of half. Okay, so basically there exists a neighborhood such that for all the points in the neighborhood, fx is continuous. So So let's say we have a del like this. For I'm so sorry. This will be, I mean, the whole length will be del. This will be half minus delta. This will be half plus delta. Okay. So and this length is delta. Right. So for all the points in the neighborhood here, this will be the function fx is continuous. Okay. Let's see. Okay. Let us check. So say we take x belongs to this half minus delta and half plus delta. Okay. All right. Uh, so now as usual, so the first summation, this will be x pi square by 6. Now what about this summation? Right. Now if we look at this carefully, right, since x is somewhere like somewhere lies around here, so basically it's less than 1. Right. So this our summation, let me write a few terms. X. Oh, okay. Oh, I'm sorry. I think, yeah, this will be box. I'm so sorry. This will be box. Yeah, this will be box. So, so basically our terms will be x plus x by 2 by 2 plus x by 3 by 3. Now each and every term will be 0 because our x is between 0 and 1. Right. One more thing. We chose delta such that uh, like this half minus delta, this is greater than 0 and half plus delta is less than 1. I mean such delta exists, right? We can choose a delta such that this is part is less than 1. Yeah. So such delta exists and we can choose. I actually forgot to mention because I mean extend if the I mean we don't want to include one, and we will see why. So delta is such that half plus delta is less than one. Okay, okay, all right. So okay, coming back. So x is between 0 and 1, right? So this will be 0. This will also be 0. This will be 0. So the whole summation will be 0. So our entire function, like this, will be 0. So fx will be just only this for all x belongs to this, right? Okay. So so yeah. Uh, so let me just okay. Let me okay. I will draw this. I will draw this later. Now, so this is continuous. Okay. The above series defines a continuous function in neighborhood of 1. So yeah. So does the above series define a continuous function in neighborhood of 1? I mean no. And this is because like if we take any neighborhood, okay. So I have written here delta. So let's just take delta dash. So this is 1 minus delta dash is 1 plus delta dash. Now for 1 minus delta dash, right, for 1 minus delta dash, okay, so let me write this here. For all x belongs to 1 minus delta dash 1, right, fx is x pi square by 6, right, because it's less than 1, so the box will be 0. So this whole term will, so basically this whole term will go to 0, okay. Now, for all x belongs to 1 and 1 plus delta dash. Okay. So what will happen here? So fx, so fx as usual will be x pi square by 6 plus, notice one thing, right? If x lies around this, let's say x belongs to this part, so our the box, the first, so let me write this once again. So this is greater than 1, right? This is 1 point something. So the box of our x will be here will be 1. And now this is divided by 2. This will be 0. This will be 0. This will be 0. Right. So yeah. Basically, so basically this will be 1. So this will be not plus. I'm sorry. So this will be minus 1. Right. So this will be minus 1. Because for all x belongs to this, so rest of this term will be 0, but box x will be 1. Yeah, box x will be 1. So okay, so our f of 1 here will be pi square by 6 minus 1. So basically our graph will look like this. Okay, so let me 0, half, 1. So let's just say, like if we are considering this, so right. So this part will be pi by 2x. Sorry, what am I saying? This will be y equals to pi square x pi square by 6. Okay, so it will reach 1 here, and there will be a jump discontinuity. Because if this was continuous, 1 would be pi square by 6, but it is pi square by 6 minus 1. So somewhere around, let's say here. Okay, so something like this. Okay, so for any neighborhood we take, right, like one like is discontinuous, so there exists no such neighborhood such that in that neighborhood the whole like function is continuous. So basically the above series defines a continuous function in a neighborhood of 1. That is false, because it will not be continuous at 1. So option A and C are true. So this is a very beautiful question. uh, okay, once again this will be 1 when x is greater than 1, right? X is greater than 1. mm, less than 2 because yeah, this will all go to 0 and okay. So